Hey everyone, welcome to the seventh episode of the Coffee with Cosmos DB series. There were some good feedbacks on the last session on throttling with Cosmos DB. If you have missed to watch the session, you can go ahead and watch the recording. It's available in the uh, Coffee with Cosmos DB series playlist. If you would like to know more about a particular topic or a feature, please ask in the chat so that we can take it up and discuss in the future sessions. If you're willing to join this community or share some uh, the things that you're working on Cosmos DB, please feel free to reach out to me. And if you're joining this session for the first time, this series is all about spreading the knowledge on Cosmos DB by the experts to the community. With that introduction, let me introduce our guest for today. Today we have a very special guest, and I really wanted him to uncover the topic that we will be discussing today, which is about system of transactions and interactions. Let me add Manish to the stage. Hi, Manish.
Hey, hi, it's Ajay. Hi, how are you?
Yeah, doing well. How about you?
I'm perfect. Thanks for inviting me on this
Yeah,
show.
you can go ahead and introduce yourself, and you can give a brief introduction about the topic.
Awesome, thanks. Hey guys, this is Manish, and I'm part of Cosmos TV engineering team. Today we're going to talk about system of transactions and system of interactions. For those of you who actually came from uh, the CRM background or on-premise legacy database background, this is not new for you. Um, the system of transactions and interactions was defined pattern for getting best of both worlds. When you have a legacy environment, you have a humongous data in your at your disposal, and when you would like to go for the customer interactions, you really wanted to have a heavy duty data to be presented in as simple as possible and as fast as possible ways. We used to have this modifications. We do a lot of ETL and prepare the data to ensure that this data is getting traversed there. However, the things are getting changed. Now, cloud is a new beast coming in our way, and it is not no longer a new beast. It is basically a de facto standard for most of the application. And if you see here, this is basically talking about various aspects of the applications, which was possible when at the advent of cloud. As soon as we think about cloud, we can actually go limitless, and we can really scale ourselves into a infinite scalability model. um, if we start with the modernizing application, or if we need to have a SaaS-based delivery model, all these are pointing towards something which is data which is more meaningful and will be available as fast as possible. We would like to have um, both the systems which are capable enough to provide faster response time. Plus, we would like to have our gold repository, which is there at the on premise. Uh, First of all, if you have seen all the AI powered apps, if you have seen your application who are responding to interface, if an application which is as heterogeneous as like possible, it is basically pointing towards, hey, we would like to have a better response from that particular application. Plus, over and above that, you need to make sure that you have your application footprint available wherever the user footprints are. So you need to make sure that your applications are literally have global footprints, and how it can handle the user interaction as fast as possible. Cosmos DB is now as cloud is a de facto standard for hosting the applications. Cosmos DB is now a de facto standard for NoSQL databases. Uh, Cosmos DB has various capabilities. If I start from my favorite one, which is guaranteed speed. We provide less than 10 millisecond of latency, whether it is reads or writes. This is backed by SLA, by the way. Um, uh, from database perspective, most of the application relies on multiple calls in order to serve one request to the end user. Hence, it is important that every request need to be served as fast as possible. Um, I've seen a couple of slides where I have got to know that the human interaction time, if human need to react to something, it is latency comes is 150 millisecond, but Cosmos TV is providing in less than 10 milliseconds, such that your user, which is again a human, will get the response time as fast as possible with a blink of eye. Now, other areas which is making Cosmos DB an enterprise database, which is zero or RPO with 5 nines of availability. We have Cosmos DB is a globally distributed environment. Means that the database itself is a globally distributed. Plus, it is partitioned such that it will have scalability, which is infinite. Of course, it is subset of what data center has. So if you're more than welcome to consume entire capacity of data center. So Cosmos DB has no limits in those terms. Integrations, we have various integrations, and I'll speak about it in details. But on a very high level, we from Microsoft perspective, we always ensure that we have a integrated, full-fledged, seamless story, so that you end to end you have a solution which may be stitched with multiple services. Each services are highly available, scaling up, scaling out, depending upon the need, and the movement of data, movement of flow is completely seamless. Um, Over and above, because Cosmos DB is a newbie, still a newbie if I consider, because it's already 8th year, but we still are a newbie. So Cosmos DB has OSS APIs, such that if you have already started with MongoDB, or you have started with Cassandra and you would like to come to Cosmos DB, you can easily move your applications without changing the code. That's one of the OSS APIs benefits. Hence, you will be able to move your application very easily. Now, let me quickly jump to an application which is where things get very interesting. So let's say you have a business model. In that business model, you have like 20 odd departments, and maybe consider as I have 4 and 5 businesses, but my umbrella is one. For example, let's say a financial company who has investment portfolio, they have a loan portfolio, they have insurance portfolios. All these are different businesses altogether. But what if you like to have only single application which will interact with all the different businesses altogether? So here, Super App comes into the picture, and Super App gives you high performance and secure layer, because Cosmos TV has such capabilities. It is having open architecture, 24/7 uptime, and it has a cloud native capability, such that let's say if you are running a campaign and a lot of people are coming to your Super App, it will never fail you, so that it can scale out and give you all the clicks, because each click, if you talk about, is a business for you. And if you are losing those clicks, then it will be a challenge from that perspective. um, we have something called auto scale. In this auto scale functionality, what we do is we provide you 10x of scaling capabilities. Those 10x scaling capabilities instantaneous, means that let's say if you configure the upper bound, we automatically give you the 10% of lower bound. So we'll be charging you only 10%, or whatever you use on an hourly basis. That's a capability of auto scale here. And then when you have a performance requirement, it actually does not matter that how much data you are storing. So if you have 1 terabyte of data or you have 1 GB of data, the performance guarantee will be there for both the environment. These are key capabilities, which is again driving from that perspective. And if you see here, the most important thing is that how soon it can be deployed, how soon it can be scaling out, and it has a full elastic layer, stretch, come back, and then you can take up all the hits from a user standpoint, but at the same time you can easily save your cost because the elasticity is going up as well as coming down. So you'll be paying what you literally use. This is the high level architecture of the super app. And now I'll basically open up some more aspects to this application. So if you see here, so we have a cache which is already there in Cosmos DB SQL API. So you have a Cosmos DB integrated cache which is directly connected to Cosmos DB. It is a managed cache from our side. All the modules you see here, these are all microservices which you can think about having individual collections so that you have a complete separation of concern. There is no dependency between individual microservices, and those microservices will be able to scale out independently without affecting the other microservices altogether. I'll try to switch back to my original story of having multiple businesses. So you have multiple businesses going on, and those businesses may have a different time, peak time. They may, one business is running a campaign, but second business is not running the campaign, something like that. So those kind of things you can think about from this orchestration. And once the Cosmos DB is, getting data, you can easily use that data for your analytical processing. So you have all the data coming in, and then you can use any of your analytical engine. Either it could be Databricks or it could be Synapse Link. It can pick up anything, and you can process it. And of course, you can push the results back to Cosmos DB so that whenever service your app, microservices using Cosmos DB, it automatically takes the scoring in mind whenever they are performing any kind of search or traversals at the runtime. So this is how we think about it. But the today's topic, which is basically to give you an idea that you have. So basically, if you see here, a very bold box which is coming in here is precisely you have RDBMS and offline data sources. Now, what is this? This is basically a golden data repository. Means that you have years of data here, and those data sources will be there, whether it is online or it is offline data sources, whether it is on-premise or Azure, hosted. So these data sources will actually seek the data, and they do a processing, and legacy applications is going on, or your enterprise applications are going on. Now, in this case, if you look at this aspect, so here you have a cloud enterprise application, you have a legacy enterprise application. Those are there for some reason, and you would like to have best of both worlds. Now here, what you are going to do is you are going to get the data from your beloved RDBMS, whether it is Oracle, Sybase, you have a SQL Server, and in this picture, I'm just representing SQL Server here. And then what you do is basically you can utilize the CDC, and CDC capabilities is basically picking up the data and pushing it to Cosmos DB. Here, when it is pushing to Cosmos DB, you have a possibility to either integrate with Azure search services, so that you can have a full text search. You can have data directly going to microservices, so that your microservices will be able to provide a better response to your app services or the application. And as I think in the last slide, I actually spoken about the HTAP capabilities of Cosmos DB. Those HTAP capabilities will give you the ETL without any issues, because in fact not issues, but it will actually give you a free of cost ETL, because the cost of your processing of the data from source will not be there, read cost will not be there, and then you will be able to, as soon as you move the data is also converted into columnar store. And when you are converting data into columnar format, it automatically do a compression of 90% of almost 90%. So let's say if you have 100 GB of data in Cosmos DB, you will end up having 90 GB, 10 GB in analytical store. And from analytical store, you can basically read the data from using any of your analytical engine, whether it is Synapse Analytics or you have Databricks. I have created a small demo here. Let me take you to the demo. First of all, if you see here, this is the SQL server I have created on Azure. It's an Azure SQL server. And what I did is I have enabled the CDC here. So CDC need to be enabled. So I did the enablement of the CDC. As soon as I enable, I get all the changes into my table, which is my table CDC city. Let me add a row. So let's say if I add a row of maybe 10, source name is good source, destination is EMI transaction, and I have transaction time as runtime as transaction time. I'll just save it. Once I do that, I got the response. 1 second. Perfect. So I got the response now, and this guy has captured the change. This change is here now, and if I go to my source, which is functions. So what I did is I'm actually just doing the select star. I'm trying to get the data. So if I just get the data, what I'm also doing is I'm writing into Cosmos DB. Here I'm writing into the Cosmos DB. So let's run this application. So it's a background job, so it does not have any specific interactions. So the assumption is that it constantly reads the changes, and as soon as the changes are there, it automatically push it to Cosmos DB. So let's move to Cosmos DB portal, and this is my collection. So I'll just pick up the collection. This data is automatically copied here, which includes, of course, your required information, plus you can also add an operation type such that you know that whether it is update or it is any other operation being performed by the user. And then this could be delivered via interface, application interface as a passbook or something, and this will be a high performant environment. So you have only one query which is going to call your legacy environment or your RDBMS environment, and your RDBMS will require now minimum compute. Means that instead of handling all the read load, it will actually be taking up only the write load, and all the read load will be served via Cosmos DB now. So Uh, if I just go back to my slides, this is what we were doing. We actually having a transactional flow, and this transactional flow we started with saying, hey, I'm doing a blocking transaction, which is my payment transaction. Once the transaction get completed, I'll basically move to Cosmos DB. Um, if I have any profile updates or something in Cosmos DB, we support change feed. In Cosmos DB, if you have an updates, you can also push those updates back to your RDBMS, and it will basically ensure that you have both the data available on both the data sources. But as I said, that you need not to worry about from um, the overall cost configuration perspective. So your cost configuration will be optimal on database environment, and your Cosmos DB environment will anyways will be pay as you go. I'll quickly jump to um, uh, cost part of it. So we have something called capacity calculator. If you have one thing in mind saying, hey, what it cost me? Because if I introduce Cosmos DB, which is another database, onto my architecture, because I wanted to get the faster response time, I wanted to get the scalable and flexible architecture. So does it cost me a bomb? The answer is no, because as I said, that you have a steady you have a variable usage of the application. It'll have a auto scale, so give you a pay as you go um, charges. Hence, you don't need to worry about from a constant usage perspective. So here is a one of the here's capacity calculator comes handy, where you can specify your usage, and as soon as you specify your usage, it'll give you the number of RUs, and RUs directly get translated into the cost, how much cost you are we are talking about. Here it is a steady workload, so you can see that this once again. So I'll just copy this. So 5,000 point rate, 1,000 creates, and 100 updates costing 642. So if I just go for the variable ones, which is the practical one, you can go for 5,000 reads, and you have, for example, maybe 500 reads here. You have creates as 1,000 creates. You have 100 creates at off peak, because I'm assuming your application is still being utilized even in the off peak period. Once you click on calculate, the cost will be reduced, and you can see that previously the cost was coming as 600 plus USD, but now you can see that you're because of pay as you go model, you are able to reduce it to I'll say 6 times, 5 to 6 times I was able to reduce. However, my intent is not to show you that, hey, we are less costly, but my intent is to make sure that we are fitting the bill. We basically, when you add Cosmos DB, your overall consumption of your legacy environment will get reduced. Hence, you will be able to reduce the compute there, and you can use that compute cost to spend onto Cosmos DB, such that your overall cost will be under budget. Um, with that, I think I'm open for questions. Yeah.
Yeah, Manish, I think we don't see any questions on the chat. I didn't want to interrupt because you were talking about a bunch of cool features like change feed, integrated cache. But I have some fundamental questions to ask, like uh, from the customer's point of view. So if customers have data assets on on-prem, and if they do not want to move them, is it possible to leverage this design pattern that you explained?
Yeah. The most important thing is that when you talk about legacy enterprise application, those legacy enterprise application is data center itself. So now what we are talking about, connecting two data center, one data center is on premise, and second data center is cloud. So it is very important that we should first of all try to shed off that latency, either using VNet connection, or we can have a lease line that will help a lot in terms of chopping off the internet and connecting directly to the data center. And second thing, if you can think about either you can replicate your data into Azure, that will also help you to reduce the latency. Although this is something that's very straightforward, but there are many detailed articles available for both the concept. If you wanted to go for MPLS lease line, you can search for Express Route. We have this service in Azure, and or if you wanted to do a VPN connection, so we have VNet gateway, and that VNet gateway can actually also help you extend secure connection with your site.
Got it. Okay, thanks. There is a question from one of the audience, like he's asking, how do we relate CDC of relational database with Cosmos DB?
Awesome. So yeah, I think this CDC or chain data capture is basically to get the data as soon as it happens. So if you see this architecture is all about that you are offloading all of your reads to Cosmos DB, because all the environments is trying to pick up the data, deliver as smoothly, as fast as possible. So all the delay, we wanted to minimize the delay. So to minimize the delay, we wanted to make sure that we have the data coming in as soon as it happens. Hence the CDC is there. So you can utilize a chain data reader. So you can use CDC, and this CDC will be able to populate into Cosmos DB. There are many patterns we have available with SQL Server CDC. You can also have Oracle, chain data capture also, or you can pick up your own legacy databases, change triggers, etc. So those triggers will also give you the data back to your functions, or it could be event hub, and it then push the data into Cosmos DB.
Got it. Okay. I hope that answered this question. And when it comes to database security, right, it comes in many forms. There are a set of security controls that are designed to keep the database safe. With respect to Azure Cosmos DB, how can customers ensure that Cosmos DB connects to their application environment in a secured manner? Any recommendations?
Yeah, Cosmos DB by default is an enterprise grade database, and it brings up the world-class security features along with. So we always ensure that your data is encrypted at rest. We never allow people to connect with Cosmos DB without enabling SSL. So SSL is by default. So your transactions, so your connection between your application or your CDC to Cosmos DB is completely secure. The tunnel is completely secure. We support VNet. We support private endpoint. So you don't need to have an internet when you are connecting to Cosmos DB. So if I go back to this environment, so if you are saying that, hey, I have an MPLS lease line, which is an extension of Cosmos DB, extension of Azure environment, Azure VNet, and then this directly secure connection. So I'll just use this one. So let's say this is your data center connection, and then this is another extension you can have of the VNet, where VNet get connected to Cosmos DB, and then entire line which you are seeing here being drawn in red color. So this basically has no internet connection requirement. So completely isolated, completely secure connection is there. Plus we have a lot of security in terms of we have role-based access control, not only on the control plane, but also in the data plane as well. We do support client-side encryption if there is something that you are further interested on, and we are carrying all the compliances which are required by Azure. I hope.
Got it. Yeah, that answer. There is another one question. I think since we are running out of time, I will take one further question. This is about the Cosmos DB use case. He's saying that we use relational database for data warehousing, but how can we say that Cosmos DB is a good fit for data warehousing model?
No, data warehousing is basically how you're storing the data. Like you are basically having this golden repository. Cosmos DB comes into the picture when you need to do a serving of the data. So if you see here, this architecture says speed layer. So you have data warehouse, you have the storage, you have the data lakes. All those sources are basically to store your data. But when you need to do a serving of your data as fast as possible, Cosmos DB comes on your way. So you pick up the data, push it to, like in case you wanted to transform the data, how you would like to deliver it, you can transform the data, push it to Cosmos DB, so that when any microservices or your application requires to access it, it can immediately get to that. That's what the whole session is all about. That we are complementing the existing data sources. We are not replacing the existing data sources. That's what will give you the best of both worlds.
Got it. Yeah, thanks a lot. I guess we are on time. Thanks Manish for all the explanation and for the insights, and thanks audience for the questions. Before I close, make sure to subscribe the channel, and please do provide feedback if you have any feedback, or if you want to cover, if you want us to cover any particular topic in this forum. We will meet again in a couple of weeks. Next time, we will be talking about another interesting topic. We will go live with another special guest. Make sure to join. And thanks, everyone. Thanks, Manish. Have a good rest of the day.
Pleasure. Thanks, Sajid. Bye.